In this video, I'm going to talk about RC circuit with the DC source. RC is nothing but resistance in series with capacitor. Okay, RC circuit with a DC source. Now here I have a switch at this point. The switch is open at t equal to 0. I'm closing the switch. That's what it indicates. So whenever you see this and say if the arrow indicates opposite way than what I did in this circuit, then this means I'm opening the switch at t equal to 0. So here if the arrow indicates closing the switch at t equal to 0, that's what the difference between those two diagrams. So here I'm opening the switch at t equal to 0. Here I'm closing the switch at t equal to 0. So here at t equal to, what's going on in the circuit? At t equal to 0 minus, that 0 minus means just before closing the switch, just before those two contacts are touching to each other. Now the time frame here I'm talking about probably in milliseconds. Okay, so my hand is on that switch, ready to close it or about to close it, about to reach those two contacts. Now the voltage drop across resistor is 0 because I haven't closed the switch yet. Across capacitor is also 0, so current passing through this is 0. That's 0 minus. Now at 0 I just closed the switch. Okay, at t equals 0, these two contacts touched each other. Now what is the basic property of capacitor? Capacitor, it opposes rate of change of voltage, so it won't let the voltage change suddenly. So from 0 minus to 0, the time frame is probably in milliseconds. Okay, so it will not accept that change. I would say microseconds instead of milli. Okay, and it varies depending upon the capacitance value. Okay, so very small time I'm talking about, probably micro or nanoseconds. Okay, so the voltage across the capacitor is going to be 0. Now since I already closed the switch, it will see, the resistor is going to see all the current, all the voltage across it. Now the current passing through this is I equal to V over R or VR over R times something. I'll talk about something later. So if I take it VR over R, that is going to be 1 ampere. 10 over 10, 1 ampere. Now at 0 plus, so few milliseconds passed. Okay, after a few milliseconds, probably it might see, the capacitor might see some voltage across this, so the remaining voltage will appear across this, and the current passing through this is going to be 0.8 ampere. Now 0 plus plus, few more milliseconds passed. By this time probably 5 volt appear across the resistor, 5 volt appear across capacitor, because some more time passed, so it will see some voltage change. So basically what is going on, this time frame, the capacitor is start charging. Whenever it start charging, it will allow the current, because the current is passing through this. Okay, once it is filled charging, then it is slowly reduce the current flow in there. I mean 0 plus 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 plus, that means few more milliseconds. So probably the voltage here across the resistor is going to be 2 volts, 8 volts. I just took those hypothetical numbers, those are not the exact numbers. Okay, so 0.2 amperes. After 2 seconds, 2 seconds is very long time. Okay, so this is very long time. After 2 seconds, by the time the capacitor is going to be fully charged, voltage drop across resistor is going to be 0. Voltage drop across capacitor is going to be 10 volts. All the 10 volts will appear across the capacitor. So the current passing through this is 0 ampere. So basically what happened here, this t, okay, 0 to 2 seconds, this is called, 2 seconds is very long time. Usually the time frame is in milliseconds. Okay, so during this time capacitor is charging. Okay, while charging it allows current. This time frame is called transient state. So transient state is nothing but it's very small time frame, and this happens when the switching is going on. Okay, when I turn on the switch, turn off the switch. Okay, in transient state, okay, capacitor is going to start charging. It will act like a short circuit and it allows the current. Now once it is fully charged, it's called steady state. So in steady state, capacitor acts like an open circuit with the DC source. So in steady state, I mean, here we're talking about the DC circuit because the source is DC source. So in DC, once capacitor is fully charged, that means it passed the transient state and moved on to the steady state. Once it is in steady state, capacitor acts like a open circuit. This statement is really important. Okay, so in DC, until unless I specify about the transient state, we always talk about the steady state. Steady state is nothing but the switch has been closed there for a long time. In steady state, capacitor acts like an open circuit with a DC source. Now if I draw the graphs for this, okay, so here I'm going to have, this is the time frame, say this is the voltage drop across capacitor. Okay, so if you look at voltage drop across capacitor, 0 minus I don't need to consider, that's just before closing the switch. So it is increasing. It will not increase linearly. It looks like linear at the starting, but basically it increases exponentially. So the voltage drop across capacitor is going to be like this, exponential. So this voltage drop VC equal to Vs, which is source voltage, times 1 minus e to the power of minus t over tau. So this voltage here equal to Vs times 1 minus e to the power of minus t over tau. That is the voltage drop across the capacitor. Now when it comes to the current, initially we have huge amount of current, and slowly it will goes down. I will talk about tau in a second. So this is the I equal to VR over R times e to the power of minus t over tau, where tau is called time constant. Tau is called time constant. Time constant is represented with RC, where R is the resistance value, C is the capacitance value. So now how do you define tau? Tau is nothing but, say for example, if you look at this exponential format, which is decreasing, negative exponential format. So whenever it reaches the 37% of its 37% of its initial value, the time taken to reach 37% of its initial value, when it is decreasing exponentially. At the same time, if you have the exponential increase line, it's nothing but when it reaches 63% of its final value. Either it is reaching to the 63% of the final value, 37% of the initial value. So based on that, you can tell, we can define the time constant in RC circuit. RC circuit, it's R times C. So based on this, the current passing through the circuit is supposed to be e to the VR over R times e to the power of minus t over tau. At t equal to 0, e to the power of 0, so I equal to VR over R. Okay, as time increases, if you substitute time in milliseconds, then you can see, you can find the time. If you substitute t equal to say 2 seconds, with tau is going to be in micro, so this value is probably close to 0, so I equal to 0. So these are the formulas for VC, voltage drop across capacitor, and current passing through the capacitor or RC circuit. Okay, this is about RC circuit. I will stop this video here. In the next video, I will talk about energy storage. Thank you.